Hi students, today we are going to see about starters of DC motors. We are having three types of starters in DC motors: 2-point starter, 3-point starter and 4-point starter. Okay, now we are going to see about 3-point starter. Before learning about starters, we have to know about the necessity of starters. Why we are using starters in DC motors? The first necessity is to limit the starting current. While starting DC motor, at the time of starting there is no back EMF in the armature winding. Hence, heavy current will try to flow into the armature winding and it will spoil the motor. So the starters are used to limit the starting current. Okay, and the next one is overload protection. When there is a overload in a motor, it switch off the supply. Okay, and then no volt protection. When there is no voltage supply, the starters are used to protect the device, and when there is a low voltage also it protects. Starters are used to protect the device. These are the necessity of starters. So to limit starting current, while for overload protection, and for no volt protection, and for low voltage protection. Okay, so this is the basic structure of 3-point starter. Now we will see about 3-point starter. This is the structure of 3-point starter. So in 3-point starter we are having starting resistance. This is the starting resistance which is connected in series with the armature to minimize the starting current. Okay, the starting resistance is connected in series with the armature to minimize the starting current. And here we are having NVR coil. This is NVR coil, that is no volt release coil. Okay, when there is no voltage supply, this NVR coil will get demagnetized and release the starter arm to switch off the motor. Okay, and this one is overload release coil, OLR, that is overload release coil. If there is a if it is overloaded, it will release the arm. Okay, and then it contains the starter arm. So this starter arm is fitted in the spiral spring. Okay, and then this is DC shunt motor which is connected with the starter. Okay, these are the different parts used in 3-point starter. Okay, and here we are having field winding. This is field winding. Okay, and we are having the 3 terminals in 3-point starter. There is line, field and armature. These are the 3 terminals: L, F and A, line, field and armature. Okay, so here F is connected with the field winding and A is connected series. As I said, A is connected series with the starting resistance, and here L, line L is connected with the positive terminal of the DC supply. Okay, and here the field winding and the armature winding is connected to the negative terminal of the DC supply. Now we will see the working of the 3-point starter. When we are switching on the DC supply, this supply will go through L, goes to L and then to OLR coil. Okay, so this OLR coil, when the supply is given, passes to OLR coil, this OLR coil get magnetized and it will pass to the handle. This is handle, right? So when this OLR is magnetized and supply the power to handle, this handle touches the resistance. Okay, so due to high same time the current flow through the NVR coil also. Okay, and at same time, due to high starting resistance, a little current will flow through the armature winding. Okay, and this motor tries to rotate. Okay, when the handle moves slowly through the resistance, through the starting resistance, this resistance get reduced. When this handle moves from starting position to this ending position, this resistance, current resistance will get reduced and the speed of the armature will get increased and the motor reaches the maximum speed. When the handle connected comes to this end, this motor reaches the maximum speed. Okay, and the motor continuously rotate. It works. Okay, and then when we switch off the supply, what will happen? This NVR coil, there will not be any voltage, right? So this NVR coil releases this starter arm from here and it will go to the off position. Okay, so the motor will get switched off. Okay, so as I said, the necessity of starters, it limits the starting current. Then for overload protection, this OLR coil is used. So if the system is overloaded, what will happen? This OLR coil will get more supply, more power, and it will short circuit with this NVR coil. So when this NVR coil is short circuited with OLR, this NVR is demagnetized and then this NVR will release the starter arm. So starter arm will go to off position and the motor stops rotating. Okay, and this NVR, what is NVR? No voltage release. If there is no voltage is supplied, this NVR coil will get demagnetized and release the starter arm to go to the switch off condition. Okay, so this is the 3-point starter working principle. Okay, so 3-point starter, what we have seen, first we have seen the necessity of starters, limit the starting current, overload protection, then no volt protection, low voltage protection, and it has the 3 terminals, line, field and armature. Okay, and we have seen the working principle of 3-point starter. And the next one is 4-point starter. So this is the structure of 4-point starter, and only one difference is there. So here NVR coil, in 3-point starter NVR coil is connected series. So here in 4-point starter it is parallelly connected with the line L minus, that is, it is connected to the negative terminal of the DC supply. Okay, so here positive side is connected to the field winding, and the negative side of the NVR, one end of the NVR is connected to the negative terminal of the DC supply. This is the only difference in the structure of 4-point starter. Why we are connecting parallel to the why we are connecting the NVR coil parallel with the negative terminal means, in 3-point starter we are having the series connection with the field winding, right? So when there is a low voltage, suddenly it switch off the motor often. So to avoid that, that is one of the drawback of 3-point starter. When there will be some low voltage will be reduced, suddenly it switch off the motor. So that is one of the drawback of 3-point starter. So to overcome that drawback, we are using 4-point starter. So in 4-point starter we are using NVR coil, one end is connected with the negative terminal of the DC supply and the other end is connected with the field winding. Can you understand? This is the only connecting difference. Okay, and this here it in 4-point starter, here you are having brass arc which is also connected to the field winding. Okay, and other parts are same as 3-point starter. So starting resistance, we are having starting resistance, then starter arm, this is starter arm which is connected to the spiral spring. NVR coil we are having OLR, overload release coil, and here in 4-point starter, 3-point starter we have seen how many terminals, only 3 terminals. Here in 4-point starter we are seeing 4 terminals. What is the 4th terminal? That is the extra connection from NVR to negative terminal of the DC supply. So that is denoted as L minus. So 4 terminals are L plus, L minus, F and A. Okay, L plus is connected with the positive terminal of the DC supply. L minus is connected to the negative terminal of DC supply, then this is field winding and this is armature winding. Okay, so since it is connected parallel, NVR is connected parallelly, so when there is a small change in voltage supply, the motor will not get switched off condition. Okay, so other working principle is same as that of 3-point starter. What is the principle? When we are giving a DC supply, this OLR coil get magnetized, and when this OLR coil is magnetized, this starter arm will touches the resistance, and when the current flow increases, the starter arm moves one by one and come to this. When it comes to this end, this armature motor starts increasing. The speed gets increased and the motor starts to rotate. Okay, when we switch off the supply, what will happen? This NVR coil will get demagnetized and it will release the starter arm to off position, and the motor will be in off condition. This is the working principle of 4-point starter. Hope you all understand this video. Thank you, students.